All right, so 3.5 is derivatives of trigonometric functions. So the first one is derivative of sine. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of secant is secant x tan x. Derivative of cotangent is negative cosecant squared. And I'll scroll back up if you need it, just write them all down. Last one, derivative of cosecant is negative cosecant cotangent. All right. Did anybody need cosine sine? Is that good? Got a chance to write. All right, so let's look at the first one. We want to find the derivative of y. Y is equal to x squared minus sine x. So, well, I'll just do this just in case. Neat reminder of shorthand. So dy dx, that's derivative of y. Don't forget we also could write y prime. So just making sure, getting you guys used to the symbolism. So what we can do is take the derivative of each term individually. So the derivative of x squared, don't forget how we handle that. You bring your exponent down front. So that'll be 2x, and then you'll do 2 minus 1, or whatever that exponent minus 1. So you bring it down front, subtract 1 from the exponent. And then derivative of sine, we just saw in the relationships, is just cosine. So this would be just 2x minus cosine x. All right, questions before we look at the next one. Let's do it like this. This will be prime. All right. So in the next one, we have y equal to x squared times sine x. Here we have to use the product rule. And the product rule is, if you had the derivative of u times v, then you would do u times the derivative of v plus v times the derivative of u. So in this case, u is equal to x squared. Let me bring it down some. Yeah, u is equal to x squared, u prime, or in other words, the derivative of x squared. We just saw is 2x. V is sine x. Derivative of sine x is cosine x. All right. So that'll be x squared times u v prime, which is cosine x, plus v, which is sine x, times u prime, which is 2x. All right, so finish it off. X squared cosine x plus 2x sine x. All right, so in this one, we have sine x over x, so we have to use the quotient rule. So we have to do v times u prime minus u times v prime over v squared. And so this will be 1. So remember how that works. Once again, x, my exponent is 1. You bring 1 down front and then subtract 1 from it. So you're looking at 1 x to the 0 power, and anything to the 0 power is just 1. So that's just 1. So always when you're talking about the exponent for your variable, you bring that exponent down front. We're going to take the derivative, bring the exponent down front, and subtract 1 from the exponent. All right. So we got v, which is x, times u prime, which is cosine x, minus u, which is sine x, times v prime, which is 1, all over v squared. So that's x squared. All right, that's the derivative. All right, 5x plus cosine x. So same type of thought process. Looking at y prime to be the derivative of 5x. That will just be 5. Goes back to what we were saying with what happened here. So that would just be 5. And then the derivative of cosine is negative sine x. So that's 5 minus sine x. All right, so here, I have to use the product rule again whenever we have two terms that we're multiplying together, two separate terms that we can take the derivative of, use the product rule. So u is going to be sine, derivative of u, cosine. V will be cosine, derivative of v is negative sine. So it's u times v prime plus v times u prime plus negative sine squared x plus cosine squared x. All right, where did my other problem go? Here we go. Any questions or concerns before we look at another one? All right, so have to use the quotient rule like we talked about before. First, we can establish u and its derivative. So u is cosine x. U prime is negative sine x. V is 1 minus sine x. V prime. Don't forget the derivative of a constant is 0. So derivative of any number is 0. Give me 1 second. Let me make sure this isn't an emergency. All right, sorry about that. So V is 1 minus sine, and then V prime derivative of that 1 minus sine is negative cosine. And so don't forget the derivative of a constant or the derivative of any just regular number without the variable involved is going to be 0. So that's why 1 goes to 0. And then the derivative of sine was cosine, but we had this negative here that we had to leave. So that's why we have negative cosine. All right. So let's go ahead and put this together. So it's V, which is 1 minus sine x, times U prime, which is negative sine x, minus U, which is cosine x, times V prime, which is negative cosine x. So that's 1 minus sine on bottom, which is squared. So this is V, U prime, U, V prime, and then that's B squared down there. All right, any questions or problems with our substitution? All right, so let's simplify. I have negative sine x that I'm going to distribute. So that's negative, I want to stay black. Negative sine x plus sine squared x. And that's plus cosine squared x. That's 1 minus sine squared, still on bottom. So I'm not going to expand that binomial distribution. Just going to leave that the way it is right now. All right, so now here's where the trig identity relationships, if you had to memorize, that would be awesome. If not, you at least need to see or hold on to some of them and try to keep them in mind. So What I mean by that is this one will show up a lot. And that is on that sheet that I emailed you guys. So make sure you take a look at that or have these available. But sine squared x plus cosine squared x is going to be equal to 1. It's one of your Pythagorean identities. And notice they didn't give any, idea or hint that something like that would show up. It's just something they expect you to have in your arsenal. So sine squared plus cosine squared. And then, addition is commutative. So you can move terms around and everything like that, or use them separately or associatively. So that sine squared plus cosine squared is equal to 1. Still have 1 minus sine x squared down bottom. If I were to rearrange my terms up top, that's the same thing as 1 minus sine x. So, and just in case you need to see it, I'll write that out. So down bottom, well, on top we have 1 minus sine x. Down bottom we have 1 minus sine x times 1 minus sine x. So that's what 1 minus sine x squared is. You have that whole quantity being squared. So I can cancel out the whole quantity of 1 minus sine x, leaving me with 1 over 1 minus sine x as my most simplified way of expressing that. All right, questions? Any questions? All right, let's see. Do I want to do this one? Sure. All right, so next one. And so find y double prime, or in other words, the second derivative of y, if y is equal to secant x. All right, so secant, derivative of secant, I say sequence, derivative of secant is secant x tan x. That goes back to the relationships that I gave you originally. Oh. All right, so y double prime means I need to take the derivative of secant x tan x. So if that's the case, I need to use the product rule. Yeah, that don't look right. I'll do this. So that means u will be secant x, u prime is going to be secant x tan x, v will be tan x, and then where my stuff go? Tan is right, secant squared. All right. So now we can use the product rule in order to finish off derivative of y double prime. So we need to do u, which is secant, times v prime, which is secant squared, plus v, which is tan, times, and I didn't leave myself room, but secant x tan x. So secant times secant squared is secant cubed. And then I have tan times secant times tan. So that would just be tan squared. Just put the two tans together, leave the secant in front. All right. Questions on anything I've done up to this point? All right. So that's it for 3.5. I'm not going to go into a new section because, like I said before, like I said at the beginning of the class, trying to give you guys a chance to get on. We lost one of us, so that easily could be chalked up to bad internet service considering what's going on. So I'm not gonna go into a new section, but we are getting closer to closing out this chapter, though. I didn't mean to do that. Trying to see how many sections are left in this. I don't think that's me. Got 3.6. This was 3.5 today. So I know for a fact we're doing at least 3.6 and 3.7. So we'll see. We'll see. I'm just trying not to move too far ahead because I know a few of you still need to get started, but still haven't taken the last test and need to get started with chapter 3. So we'll pause right here. If you guys have any questions, feel free to email me if you can't wait till next class. If not, most definitely we can address them next class. Outside of that, go ahead and knock out that test, and let's get rolling in chapter 3, because like I said, soon we'll be done with chapter 3 lectures, and we don't want to have all the stuff just floating out there. So if you guys are good, I'm good. I will see you on next class. Have a great weekend.